Okay, in 3.3, we're going to differentiate inverse functions. Before we do, let's consider inverse functions again. Okay, g of x is the inverse function of f of x if, notation-wise, if g of x is the inverse of f of x, we say f inverse of x, and we use the -1. It looks like an exponent, but it's saying f inverse of x equals g of x. Be careful, because if this is, sometimes -1 means it's an exponent that's -1 and it makes a reciprocal. In this case, they're saying f inverse of x. Okay, if they are inverses of each other, then they undo each other's functions. So what would be true? Let's see. If, let's say f of 3 is 5, if they're inverses of each other, then g of 5 would equal 3 because the x's and y's are just switching places. Okay, what else is true about inverses? Inverses kind of cancel each other out. So if I do f of g of x, the f undoes the g of x, and then they cancel out to get x. And the same is true if I do it in the opposite order. If I do g of f of x, they would also cancel out. And they would equal to x, which is how you learn to check whether two functions were in fact inverses of each other. Okay, this is the formula for the derivative of an inverse function. Okay, so the derivative of f inverse of x equals 1 over f prime of f inverse of x. Okay, before we even try to use that, I'm going to show you, I'm going to show you where the formula comes from, just because it helps me remember the formula if I kind of see where it came from. But you won't ever need to show me where it came from. Okay, I'm going to put it up here since I don't actually, you don't need to know this. Okay, so if f and g are inverses, or inverse functions, okay, then it must be true that f of g of x is equal to x, because that's a property of inverse functions. They would cancel each other out. Okay, now if I want to do the derivative of f of g of x, I could do that. I'm going to take the derivative of the other side to balance it out. Okay, if I do the derivative of f of g of x, I'm going to use the chain rule. So the outer function is f of x. So if I do the derivative of f, that's f prime of g of x. And I'm going to times it by the derivative of the inner function, which is g prime of x. Okay, the derivative of x is just 1. Okay, now if I'm trying to find the derivative of g of x, because g is the inverse function, okay, I'm going to divide this expression to the other side. So I'm going to get 1 over f prime of g of x. Okay, and since f and g were inverse functions of each other, g is the same thing as saying f inverse, which is how we got that the derivative of f inverse of x equals 1 over f prime of the inverse of x. And no, I'm not going to ask you to do that ever, but it helps me remember it if I kind of remember where it came from and why there's this weird fraction situation going on. Okay, let's look and see where we might use this. Okay, so for example, when I'm given this table and I'm told for part A that g of x is going to equal f inverse of x, and they want me to find g prime of 1. Okay, so g prime of 1. Okay, now g is the same as f inverse. So I'm finding the derivative of g of x at 1, which means I'm really finding the derivative of f inverse of x at 1. But I don't want to say f prime of -1 because there's so much stuff going on. So I'm going to say I'm going to find the derivative of f inverse of 1. Okay, if I'm doing the derivative of the inverse function, then I'm going to go ahead and switch up to this crazy formula over here. Okay, so let me just write it and then I'll stare at it and try to figure it out. So it's 1 over f prime of f inverse of 1. Okay, let's go ahead and look at the inner function first because that's going to be our first thing to tackle. Okay, if I want f inverse of 1, since it's the inverse, I'm actually trying to figure out where f of something is equal to 1. So let me look at this table up here. If I want f inverse, I want to figure out where does the function equal to 1. So I'm going to look in the second column. F of x is equal to 1 here when x is 2. So since f of 2 equals 1, f inverse of 1 is actually 2. Inverse is inputting the y value and giving you the x value. Okay, so let me rewrite this now. So this is 1 over f prime, and then I've established that f inverse of 1 is actually 2. Okay, now let me look at the table for f prime of x. F prime of 2 is negative 2. So this equals 1 over negative 2. Okay, and then that's my answer. Okay, part B. Write an equation for the line tangent to f inverse at x equals 1. Okay, since I'm finding the line tangent to f inverse, I need the derivative of f inverse at negative 1. I found the derivative of f inverse at 1 right here, so the slope is going to be negative 1/2 for the tangent line. Okay, what's my x and y value? Okay, well they're saying to do it at x is 1, so x is 1. Okay, now what's my y value of f inverse? So if I do f inverse of 1, I figured out that was 2 because when the y is 1, the x is 2. So for my y value, I'm going to put a 2 here. And then this is the equation of the line tangent to the inverse function at x equals 1. Okay, let's try another one. Okay, let g be a differentiable function since that g of 12 is 4, g of 3 is 6, g prime of 12 is negative 5, and g prime of negative 3 is negative 2. The function h is differentiable, and h of x equals g inverse of x. So h is the inverse function of g. Okay, find h prime of 6. Okay, let's get to the question now. Okay, I'm trying to find h prime of 6. Did they give me? They gave me no information about h in any of these data points, so I'm going to have to use the fact that h of x is the inverse of g. So I actually want the derivative of the inverse of g at 6. Okay, which means I need to use the crazy formula. Okay, so according to the formula, I'm going to do 1 over g prime of g inverse of 6. Okay, and I'm going to do the inner parenthesis first. So let me just look at this part. Okay, so I want to figure out what g inverse of 6 is. Hold on, let me write inverse correctly. G inverse of 6. Since it's an inverse, I'm trying to figure out where the y is 6 and what x value gives me a y value of 6. So where is it? G of 12 equals 4, g of 3 equals 6. So since g of 3 equals 6, g inverse of 6 is going to equal to 3. Weird, yes? But if it's inverse, you look for the input that gave you that output. Okay, so now what do I have? I have 1 over g prime of 3. Hopefully they gave me what g prime of 3 is. G prime of 3... No, it's supposed to give it... No. Okay, let's pretend like this is positive 3 and then I'll change it on your notes. Okay, so g prime of 3 is going to be negative 2. So this is going to be negative 2. So what was I finding? H prime of 6 is going to equal to negative 1/2. Okay, let's try one more. Okay, they're telling me if f of x equals 3x to the third plus 1, g is the inverse of f of x. What is the value of g prime of 25? Okay, so I'm trying to find g prime of 25. And I do know that g is the inverse of f. So I'm trying to find the derivative of f inverse at 25. Let's go ahead and look at that formula. So this is going to be 1 over f prime of f inverse of 25. Okay, let me try to figure out what f inverse of 25 is. Okay, what did they give me? They gave me the equation as f of x equals 3x to the third plus 21, or plus 1. They want me to figure out when f inverse is 25, which means they want me to figure out when the y value is 25. And I'm trying to get the x value as my output of the inverse function. So let me solve this off to the side real quick. Okay, so what do I have? 3x to the third plus 1. I want to see when that gives me 25. Okay, x equals 2. So f inverse of 25 is 2 because f of 2 is 25 if I were to plug it back in. Okay, now let's keep looking at this now. Okay, now what's f prime of 2? Well, I know f of x is 3x to the third plus 1. Let me do this off to the side now. Okay, so if f of x is 3x to the third plus 1, f prime of x is 9x squared plus 0. So if I do f prime of 2, 36. So then I'm going to get 1 over 36 for g prime of 25.